Hi everybody. In this video, I'm going to take the example code from part 2 of exercise 8, do a walkthrough of just how to adapt that to our local environment here in central Massachusetts. So if I just run it as is for this area around El Rosario in central Honduras, um, we're getting from February, March 2009, a Landsat 7 image, filtered by date by time, but also by cloud cover. That information is printed out to the console. It's going to be assigned some visualization parameters and added to the map. That's this erroneously labeled LS5. Could make that a little better. Next time I run, it'll be LS7. Um, we also have that spectral information in that image being classified using a regression tree into one of, what is that, 5 different categories: water, irrigated ag, rain ag, forest, or bare/built. That's also added to the map here. And we got the different colors here. So there's the false color composite, and then here coming in over it is the classified output. Red being the bare built, bright green being the, we'll call it low to moderate productivity agriculture, pasture land here. Um, the yellow, supposedly a high productivity agriculture. It's not really doing a great job of mapping that, but the script shows how to generate an output. And then all the black here, the dark, is forest, and it's also capturing the clouds. So how to adapt this to central Mass? So the first thing, we don't want the map always returning to Honduras. So if we're going to keep this center object method passing geometry as the argument, we're going to have to change where geometry is. Geometry is that rectangle. Get rid of it. Zoom out. For Massachusetts. And I'll add a new geometry. So now when I run, we're centering the object on geometry, and we're using that rectangle to spatially filter the Landsat data, but none of the training data is in this area. So we're going to have to make new training data. That's pretty typical because we can't take it for granted that the categories that are comprising a large portion of the landscape in Honduras are going to be the same as in Massachusetts. So I'm going to go one by one, delete all these. Maybe I can do it quicker up here. But before I delete it, we'll take a look in one of the settings. Edit layer properties. So it's got a name, it's got a color, sure. It has a setting to import it as a feature collection, as opposed to a geometry or a single feature collection. And it has a property here called class. The value is 0. If I look at a different forest here, or screen feature collection, it has that same property called class, but the value here is 1, and so on. So all of those look the same except for the specific number, the value of the class property. Starting at 0, and then we just increase by 1 for each category. So let me see. Bye-bye. Let's see, I don't want to deal with these scan line errors. Can I just work with summer 2018 data from Landsat 8? Does that work? Change it everywhere. Change the name, be sure of that. Okay, so we're getting some data. How low can I go on the cloud cover filter? There we go. If I set it to 10, it looks like the data is pretty good here. So the bands are a bit different. Remember, Landsat 5 and Landsat 7 are essentially the same spectrally and radiometrically, but for Landsat 8, there's this coastal aerosol band. Blue is band 2 here. So if we want the same kind of composite, I'm going to have to change it a little bit. And when we're doing a classification, we don't want to skip band 6. There's no reason you would know this before, but band 6 in Landsat 5 and 7 is the thermal band, whereas in 8 it's 10 and 11. So if you're working with Landsat 5 or 7, you're looking at spectral bands. You go 1 through 5, skip 6, and add 7. Here we can go 1 through 7, all. Doesn't matter what we visualize, but we would like that in our prediction bands here, the basis on which we're going to allocate every pixel. So I'm going to have to come up with a new training features. I don't have any more geometries, so we're going to have to make them. Before we make them, we need to think about the information classes, the real types of land cover that we see in these landscapes. So I'm going to turn on the satellite base map, turn off that rectangle, and we'll zoom in. Now, depending on the purpose of a map, of a classification, you might choose different categories. For this, it's a learning exercise. We're interested in forest and forest loss, expansion of maybe residential development. So when we think of the different materials, sure, we see concrete here, a lot of that, kind of dark roofs. See lightish, maybe yellowish green, open grass, and then darker green trees. We zoom out a bit, we can see water too. Kind of as a minimum, it's kind of cloud free. If we zoom out, we see fields, trees, concrete, asphalt, and water. So we can just, use those four. Built, could not import it as a feature collection. This is going to be important in order for us to use it as training data. Add a property, we'll call it class, and we'll start with the value 0. Built, grass, the next one, imported as a feature collection, class, this time a value of 1. Forest, feature collection, class 2. I'm not worrying about these right now. And then water, import as feature collection, class 3. Let's see. So now we do have them in the top, errors notwithstanding, but there are 0 elements in each of these. So now we're going to use these editing tools to give those categories elements. Oop, not like this. Let's see, get the hand on. We'll zoom in to an area, west side of Worcester here. We've got some water, we've got the airport, some grass around there, and forest. But when you want to add points or an area, you can sketch out a polygon for one of these feature collections. Click it in the imports, here built, and then one of the editing tools. So here's the pointer. So I'll just put a point right on that airstrip. 2. Put one on the top of this building. 3. Top of that building. 4. It's going to be better to zoom in. And remember, what we see in the satellite isn't necessarily the same as the Landsat. So there might be some little spatial offset. With that pixel right there is one we're going to identify as being a road, so built up material. Here's a lake. So if I click here in geometry imports water, now I'm going to be adding elements to water. How does that look like? It looks kind of dark blue in our Landsat. Add a few points here. If I want to, if I see a lot of open water, I can also add a polygon, like so. And it's 3 elements, 2 points, a polygon. You can mix it. As I zoom in, I see that what I tried to put on a bright rooftop is actually a slightly different pixel. If you need to edit this, go back to build. Oh, go back to build. Click on the hand. And then you have the option to either hit the delete key or press delete here. And it went from 5 to 4 elements. I can put it on the better pixel if I like. Let me see. There we go. So let's see. I don't have the visualization parameters great on that Landsat. I'll just come out. Still using the satellite. Keep in mind, if we're not working with very recent data, if you're working with the 2001 Landsat data, for instance, there could be actual, real, extensive differences. Forests could be cut down, roads extended. If you're looking within a year or so, the pace of development isn't so great around central Mass. So for forest, you can sketch out a polygon right here. Maybe for fields, we'll go right here. Looks like a golf course. So all these kind of little bit lighter pink, that'll be grass. Grab some of those pixels here. Now let's see. We might add a little bit more forest. We'll see how it works. When you are doing this, you'll want to do a better job than I just did. You'll want to pick out more elements. You want to make sure you've got some good ones. This is not very many, but we'll see if it works. So we got feature collections called built, grass, forest, water. We're going to merge those all together, excuse me, to make this training features variable. So we'll just built, merge, grass dot merge forest.merge water. So here, the classifier training. Essentially, if you pick a lot of input data for training, you can choose to only use some of it to train the algorithm or to teach the algorithm how to separate pixels. You can withhold some to assess the accuracy of that. So if you have this, you put in the name of the image, .select prediction bands, .sample regions. So collection training features. That's kind of the merged feature classes. Properties, the one called class. Be careful about capitalization. So right here, it's lowercase in the script and lowercase in this property, which is what we want. It could be uppercase in both, as long as they're the same. The classifier here is a Cartesian classifier and regression tree. We're calling the .train method on it. Passing features, the merged feature classes, specifically with that property called class, and then inputting the prediction bands. So that's coming from the Landsat data here, band 1, 2 through 7. Classified is going to be that image, selecting all the bands, calling the .classify method on the image and passing it this classifier. Then we're adding it to the map, minimum 0, maximum 4. Change that to 3 because we have one fewer class. Red for built, okay. Call it yellow for grass. Green, green for forest. Get rid of this one, and water can be blue. So there's our Landsat 8, and here's our classified image. So let's see, we have 4 different colors here, red, yellow, green, and blue. Red is covering most of the downtown Worcester here, built up areas, the airport. Yellow appears on a lot of the fringes. Green around. So that's good, I guess. And then there's a whole lot more water, a whole lot more blue than there really is. But I can pick that on and off. You can compare it to the Landsat 8 data from which it was generated. You can compare it to the satellite data. So this gives us an output. It's not necessarily a very good output. This is probably, at this point in the assignment, you'd want to revisit your training data. The classification and output is only going to be as good as the training data. And so you would want to go back when you have as few points as this. I mean, you can assess each individually. Really, you don't want to attempt to make an output until you have better inputs. Particularly, it looks like water is causing us the most trouble. I only put down a few points, a little bit of water here in a lake by the airport. That lake might be seasonal. You know, if the lake fills in, if it looks like we can see it in the satellite data, or the satellite base map here, the high res data. But if you want good reading for water, go to deeper water. So Lake Quinsigamond on the east side of Worcester, some of these reservoirs to the northwest. That is going to be a better one. The other thing, it's confusing to me as I look at it. The color coding I used in the output of the classification is different from the one that our feature collections are being shown with. So for your own sake, you might change those. I don't think it has to be perfect. correspondence between the classified output and your training points, but make water blue. Just save yourself the trouble. So here we go. Get some imagery here from summer 2018. Use those time bounds, the geometry rectangle, and a filter on cloud cover to pull up some images. So that's this image collection object. Features list 4, so 4 images with less than 10% cloud cover from those 4 months. Here I'm specifying visualization parameters to add a mosaic of this collection to the map. So sorted on cloud cover, even under 10%, mosaic those to come up with an image. You could clip this to the county if we were using the county in this example. Added that to the map. Set out a list of strings that are going to be the prediction bands. Merged our training features, feature collections, sorry. Have this bit of code here to sample the regions. With so few points, maybe that's one of the reasons, that's one of the things that's causing us a headache. Here, specifying a classifier or building that classifier object. On line 37, we pass that classifier as the argument for this classify method on the image, temp mosaic, and then add that output to the map with these visualization parameters.